Let's talk about images and containers in a little more details. As we know, these are the read-only templates on which the containers are built. The images package the software along with all of its dependencies, and it is the image which is shipped to the production deployment environments. Hence, we can say that in the Docker lifecycle, images are equivalent to the build or packaging aspect of it. You can also say that this is the code base which, when run, gives us the containers. One way that the images can be shared with others is by using a registry. Alternatively, it can also be saved as a standalone archive file which can then be loaded to another Docker host. If a newer version of the image is published, the local copy can be updated with the newer layer of that image. Remember, we discussed earlier about the union file system that is followed by the images, so same concept can be used here. As we have seen earlier, there are two ways to have images locally. Either you can build it from scratch, you can build them, or to use images created by somebody else. An image doesn't have to be necessarily built from scratch. We can use an existing image as a base for our new image. If we are building on top of those, you can do that. As we discussed, there are two ways of getting images onto your local Docker host, right? So either create them or get them from somewhere else. In this slide, we will cover this aspect in detail. There are two ways of creating a new image. First one is to use a Docker file. Now, Docker file is a text document which has a set of instructions provided for building the image. The instructions are read sequentially, top to bottom, and the image is created based on the commands provided in the instructions. Since the images use union file system, each command adds on a layer on the previous one to form the final Docker image, right? Now let's take a look at the Docker file which is there on my test system. So let's go back to the let's go back to the putty session here. I'm in let's just connect this. I'm in the image1 right now, directory now. Here's the Docker file, right? So it has the, if you look at this, it has the instruction in text format which the Docker engine uses to form the Docker image. We will go through the Docker file instruction and actual building of the images in depth in the coming modules, right? So for now, let's get back to our topic and let's look at the other ways of creating an image. Let's look at that. So the other way of creating an image is to use the Docker commit command to convert a running container to an image. Remember, a container is a running instance of an image, right? So let's say you already had a container running from an image. You made some additions to the container and now you want to save it by converting it back to an image. So now whenever you will run a container from the new image, it will have all the additions you made earlier. In a way, we can say that the Docker commit is kind of reverse engineering command, right? Because you can go back and look actually what is there. Now, once the images are built, how to share them? That's the other way of getting images onto your local Docker host. There are three ways to do so. So let's have a look at that. First is to publish the image onto the default registry, which is the Docker Hub. The Docker installations are pre-configured to use the Docker Hub as the default registry. So if you pull or push an image without changing the default Docker registry, it will always point to the Docker Hub. We can access the Docker Hub on the browser. So let me just go back to the browser and I'll show you how to access the Docker Hub. So let's do this. Okay, so here it is, the hub.docker.com. Now I'm logged in with my credentials on Docker Hub. Now I can search for the available repository of MongoDB. So let's say I'm searching for a MongoDB, right, which is by name Mongo. Okay, now scroll down a bit. There are these tags available out here. There are multiple tags available here. So let's say I want to download the image with a tag. Let me see, with a tag, say with a tag say Cilian. Okay, so I will go to my Docker host and type the docker pull mongo, right, command using this Zillion tag. Okay, so docker pull mongo from this particular tag, which is your Zillion. So now, and hit. So now it is downloading the image for the tag specified. It is downloading layer by layer. So if I now check the images available on my host, I see the MongoDB. I should see the MongoDB image. So once it is complete, we will go and check. So let's go ahead and check this one. Docker image ls, right? So there you see the Zillion one, the image which I have downloaded. Okay, so now the second way is that instead of using the Docker hub, you can create your own registry. It can be hosted on the public private network or inside a corporate network also. The access then can be restricted as well, and hosting a registry is part of the syllabus, and we will cover that in the future modules in detail. As a developer, if you have created an image and you want to share it, then you need not necessarily share it using the registry. It is also possible that you create an archive, create an archive of it is of, or maybe a tar file, and share the file. The archive file can be imported on another Docker host. Now let's talk a bit about containers in this slide. I believe it would be clear to you by now that containers are running instances, and they are the execution aspect once the image building is done. One container would have one or more running processes. Generally, if we speak of microservices architecture, one container gives one specific service only. Now there could be more than one process inside a container providing the service. Now there is isolated environment provided to the containers using the namespaces. Because of this, a process running inside a container has visibility only within its container, nothing else. Okay, a container runs on an image, but it cannot make any changes to the original image. This is very important to understand. Since the visibility of a container isn't beyond itself, it cannot access the file system of the host as well. Any additions made in the container or any changes introduced inside the container remains inside the container. The data can, however, stay as an external volume. So on this slide, since Docker works on union file system, let's put things in that perspective and try to understand. A container introduces a writable layer on top of the image. That is, when you run a container from an image, the running instance gets a writable layer. The image by itself doesn't have a writable layer. Why? You guessed it right. Image is read-only. Once the image is formatted, it cannot be altered. You can create another image on top of the original image, but the original image cannot be altered. In the diagram on the screen, as you can see, the image in the first container is based on CentOS image. Okay, there are two layers added on the base image, as the image uses a layered file system. The container adds a writable layer on top of it. The image of the first container can be used as the base image of another container, while adding another layer on top of it. This way we can build on existing images. When the container is spun from the image, it will, as always, add a writable layer on top of it. Any write operations that is done on the container stays in the writable layer only. When the container is deleted, the writable layer is also deleted, which is obvious as the layer was introduced by the container and was a part of it. You can have multiple containers running on the same image, but totally different data in their respective writable layers. So in this slide, we will look at the most common workflows that are associated with Docker images and containers. Images can be built locally from a Docker file, and images are pushed to Docker registry in order to share them. For a Docker registry, the images can be pulled on a local Docker host. There is yet another way to share images, which is to save the images as tarballs. Okay, which can be shared between systems. The image inside a tarball can then be loaded onto the local Docker host. It can further be used normally to run containers or to be used as a base for other images. Containers can be run from images. A container can either be in stopped if running, started if stopped, or can just be restarted. It doesn't lose the writable layer until the container is deleted. If you have made significant contributions to the writable layer of the container, it can be committed back into an image. In such a case, the data in a writable layer gets converted into the images layer and can be distributed.